going on, Algebros? In this video I'm going to do a couple more sketches of log functions, and let's dive right in. So we're going to start with example 3 where we have log base 1/2 of x. Notice that 1/2 is our base a, which this time is less than 1. So prior to transformations, if there are any, this graph would be decreasing from left to right. So like we did in the previous video, let's go ahead and make a little table for x, and then log base 1/2 of x. Prior to transformations, these would be 2 points on the graph, 1 comma 0 and 1/2 comma 1. Let's go ahead and plot those 2 points, 1 comma 0 and then 1/2 comma 1. And here you can see that, to the left of 1 comma 0, we'll have an end heading up towards the positive part of the y-axis without ever crossing or touching it. And then to the right of 1 comma 0, we'll have an end slowly decreasing to negative infinity. That qualifies the y-axis as a vertical asymptote, the left end of this graph does. And there are no alterations to the format of the function, so that would be our complete graph. Let me just indicate 1 comma 0 on it. And let's talk about the domain, range, and all that good stuff. So no alterations, in other words, no transformations present. We just wanted the basic graph here. For that reason, the domain is from 0 to infinity. The range would still be all real numbers. Equation of the vertical asymptote at x equals 0. And then 1 comma 0 stays at 1 comma 0. So that would be a rough sketch of log base 1/2 of x. Let's move on to example part 4, where we have log base 2 of quantity x plus 1. So here we are going to have a transformation because there's a small alteration within the argument. We have x plus 1. But we'll still start by identifying the base a, which is 2, and that's greater than 1. And I'm going to make a mini table for log base 2 of x. So this would be the most basic version of this function, in particular the function without a transformation. So without transformations, 2 points on this graph would be 1 comma 0 and 2 comma 1. So I'm going to plot those 2 points, 1 0 and 2 comma 1. And since there is a transformation, I'm going to dash this graph because it's not my final graph. I'll call that graph 1. So the only alteration is within the argument, in other words, within the grouping symbol. And like it did for us before, any addition or subtraction within the grouping symbols is going to create a horizontal shift. In this case, it's a horizontal shift, and we always have to think opposite. So what's going to happen is our graph is going to move to the left by 1 unit. So I'm going to take each of these 2 points that I previously plotted, and I'm going to move them to the left by 1 unit. Actually, I'll do those points in red. And something else moves to the left by 1 unit. You think you'll be able to identify what does? Well, the other thing that moves to the left by 1 unit is the vertical asymptote. So I'd like to include that before I connect those 2 points. So that would now be going through x equals negative 1. So to get my final graph, I'm going to connect these 2 points while going to the right and slowly increasing to positive infinity. And then going to the left, this end of the graph would curl down and approach the vertical asymptote of x equals negative 1. And keep in mind that that end does not cross or intersect the vertical asymptote. That would be the final graph, and I'll indicate the new location of 1 0. That's now at 0 0. And let's talk about the specs of this graph. Domain, range, vertical asymptote, and new location of 1 0. So one way of finding the domain algebraically is to take the inside expression, or in other words, the argument of the log function, and set it greater than 0. So if I do that, I'll do it off to the side. I'll say x plus 1 is greater than 0, and solving for x would give us x is greater than negative 1. So that would tell us that the domain would be parentheses negative 1 comma infinity. And that's probably something that you could have even identified from your graph. This graph is entirely to the right of x equals negative 1, and we also have a portion of the graph that gets close to that x value without crossing or touching it. The range would still be all real numbers, though. We have one end going down to negative infinity, another end going up to positive infinity. That would be these guys that I'm referring to. And the graph is fully connected, so the range would be all real numbers. As noted on our sketch, the vertical asymptote equation would be x equals negative 1. And also noted on our sketch is that 1, 0 relocates to 0, 0. And there we have it. A basic log function sketch and a log function sketch where we have one transformation. Okay, so you can probably tell in the next video I'll do some additional sketches where we have more transformations. But in the meantime, let me know if you have any questions about this one. Otherwise, thanks again for watching, and I'll catch you in the next one.